Okay, we'll start. Okay, I think in previous classes we were covered virtual pointers. Okay, and things related to static polymorphism or runtime polymorphism, or some problems with respect to polymorphisms and all. Okay, so today we'll look into concept by name v pointers and vtable. So virtual pointers and virtual tables. What is it, or how uh, a compiler gives us this polymorphic capability for us to implement any runtime polymorphism and all? How this can be achieved? Uh, how this is achieved by the compiler? Like this is not something which we can use. V pointer, V table, we cannot use it, but compiler introduces it and uses it. And uh, most of your interview questions, if people want to ask, they will ask you like, what is vpointer, vtables. So if you say I know runtime polymorphism and all, they might ask you these questions. So that's the reason I wanted to cover this topic. Okay. So v
Okay.
pointer means, or vtable means virtual pointers or virtual tables. Okay, virtual pointers or virtual tables. You can give an expansion to them. Okay, so a very good examples or vast coverage wala link I am sharing you. This is one link where they have covered everything in and out of this virtual pointers and all. So we can understand what it is. Okay, so first, let me. Okay, v pointers in C++. Okay. So what is virtual table? The V table, it's a table of function pointers. It is nothing but a table of function pointers that is created by compiler to support dynamic polymorphism. Okay. So whenever you write a class, okay, whenever you write a class, okay, and the moment you say virtual or the sorry for this. The moment you put
No,
yeah,
breaking,
go.
sir.
Am I
Voice is
breaking still?
breaking,
Okay, let me connect once again.
sir. Yes, yes.
Is it fine now? Sakalya, are you able to hear me now? Fine.
I'm able to hear.
Hmm. Okay. So I think previous classes, I think I covered the size of a class, correct? Not completely, but some part I have covered, like how we can find the size of a class. It is depends on number of members that are part of it, like number of variables that you declare and the size of each of them. Okay. So, here, when you add any functions, right? Okay. Generally, they don't become part of class size. Class, when you say size of a class, the pointer for a function doesn't become part of it. Okay. But when you add one virtual keyboard, at least one virtual keyboard, na, so what happens? The compiler will allocate one, okay, one pointer inside it. Okay, one 4 bytes it will allocate, one pointer it will allocate, and use that is what we call it as v pointer. Okay. Now, how does it allocate it? What is the benefit of it? We'll show you. Okay. Now, assume this is a class which has three function: function one, function two, function three. This has three functions, but one of them is, at least one or all the three are virtual. Okay. Now, if you see, what compiler does is, the moment you declare a class, okay, with three functions, right? So it will allocate a variable by name vptr inside it. Okay, it will allocate a internal or hidden variable v pointer by inside it. And what does it have? So the basically v pointer will point to the virtual table. So the contents of v pointer will nothing but it will has the address of the virtual table. Okay. Now inside that virtual table, you will have addresses of function one, function two, and function three. Okay. See, the base class have three virtual function one, function two, function three. Okay. So the class v table of the base class would have three elements. Okay. Which is nothing but that is the function pointer to all this base function two, three. So it will have, so the compiler will create one table and keep it inside its memory. Okay. And it will just give you one vptr, and this will have the address of this vtable. Okay. Sorry guys, I got breakdown in between. Am I audible now, right?
Yeah, yes.
Sorry guys. Okay. Okay. Now we'll talk about a derived class. Okay. Now base class, I would like to repeat with the base class has one v pointer which will point to uh, the base class का v table. Okay. Now similarly, when you write a derived class, okay, when you derive a class from a base, okay, so by default the base already has a v table, v pointer, and it will point to its table. Okay. Now you see v table of base class. Now the moment you write one more class derived, which is derived from the base. So here you haven't written it in this image, that is missing, like it is derived from base. So what it will have is, it will also have its own v pointer. This guy is going to have its own v pointer. Now you see, now this guy has v function. Okay. So the moment he declare the v function here, it is nothing but he is overriding the function for function one which was written in the base class over here. So only for this function the address will change. Okay. In this, so now this v pointer is going to point to this table, but in this table the address of function one is going to be from derived, whereas the address of function two is going to be from base class, and similarly function three will also be from base class. I'll repeat again, or you want me to repeat again, or you guys have any doubts on this concept?
So repeat one.
Okay, good. That's good. So, uh, so the concept here is, what is v pointer and v table? Okay, and what is the importance of it? Okay, so the compiler will give us polymorphic capability. The compiler will give us polymorphic capability by introducing a v pointer inside a class. It will write by itself. It is not something you write, I write, or anyone else write. The compiler will put a v pointer inside it the moment you declare one function as virtual. Okay. So the moment you make it virtual, na, so it will introduce vpointer by itself, and the content of this will point to a vtable. Okay, I'll show you in a program. So this is the theory. Okay, now how many functions that you declare as virtual? So all those functions address will be stored in the vtable. This is again stored in the compiler. This is not something which you can use for coding at all. You cannot use this for coding. Okay, so only few of them you can use, but that is not recommended way of using at all. It is not used at all. But this is how it stores. Okay, now the moment you derive one more class, right? Okay, derived one. In that, if you are going to override one more function, right? Okay, so in one more function, what it is going to do, it will have its own table again. Now here, if you see, the base class has one table. Similarly, he will give the same table here. Now for derived also, he will give you one more table, but only in that, since you have overwriting this function address, na, this function address you are overwriting here. Here the implementation is different. Here the implementation is different. That address will be changed for this. So it will point to a table which will have three functions, and first one will be the address of this function, and these two will still have the address of these functions. Okay. So next, let's see. Next, what is this? Next, we have same one more level derived function. Now, what he has done uh, here, derived two, he has derived from derived one, and in derived two, he has overwritten function two. Okay, so the table that is assigned for him will have function 2's address which he has declared here, and function 1's address which he has overwritten here, and function 3 he has both the classes has not overridden it, so it will take the address from the base class itself. Okay, so I'll show you a program. That's a best way to see this. Let me use online GDB today so that we can do it fast. Here, okay. Here I just declared a class, okay, which has nothing inside it. So what would be the size of this class? A class having no elements, nothing inside it. What should be the size of this class? Maybe I covered in third and fourth class. What is the size of an empty class? I think someone asked these questions also. I think I came back. So the size of an empty class is going to be 1. It is just going to be 1 in C++. Okay. Whether it's size of a class or a size of a structure, the size is going to be 1. Now if you see, I have declared a class which has no functions or no variables. The size of this is returned as 1. Okay. Now address of object mean whatever the instance that you create is called address. It has no value for us, I think, for our demo. So in this, if you see now, there are no functions, there are no virtual functions at all, there are no variables at all. The size is just 1. Now let me add a class which has two variables. That is also not required. Is this? Hmm. Now, if you see in this class, what did I add? Just a simple function. Okay, I just added a simple function. Now tell me what is the size of this class? What should be the size of this class? Guys,
1 byte.
the, yeah, it will still remain 1 byte because this is still a empty class, because the function has the class it may have functions, but functions are just scoped but defined from outside. They are just scoped. See, the size is still 1 byte. Okay, that is by default. Now, if I make the same function virtual, see, it is the same function. Okay, no difference. I just added a keyword by name virtual to it. Now let's see what is the difference. See, the size of this is 8. The size of this is 8. It is nothing but what it does is it is allocating a pointer, a function pointer or v pointer. It allocated it has introduced this inside our class. Inside this class, it has introduced this. Okay, because of that, the size has become 8. So I can only show you this theoretically. It's just like assumption. I cannot open and decode and show you that. Okay, because there is no way I can access the v pointer table in C++. It is just a theory. So that's the reason I'm just giving it as a theory. Okay. So now what if I add one more function 2, and it is again virtual. Now tell me what should be the size of this class? Any guess? What should be the size of this class? You can take a guess. It's okay. It's fun of all. Okay.
16.
Hmm? No, because see what it does is, so as per the theory I explained, it will allocate just one pointer, v pointer, but this pointer will point to a table. Table is nothing but you can say it's an array of pointers. So this array compiler will create and it will store there. Only thing, uska address it will have here. Okay. So the size of the class will remain same whether you are writing one virtual function or two virtual function or 100 virtual function. It doesn't matter. It will remain 8 it is. So the moment you add virtual, it is internally uh, adding a pointer. The type of it and all is also not known or not accessible. Okay. So no matter how many functions you add, virtual functions you add, the size will remain 8. Now I can remove this function 3, or I can make it as function 32 or whatever. Now also what should be the size? It should remain 8, because there are no variables apart from this vptr. For this function pointer, I mean the table pointer, it has allocated the size as 8. So got it right? Any doubts on this? Let's see. Let's see what should be the size of this pointer. See, so ptr is nothing but a pointer, whether it's an integer pointer, char pointer, class pointer, whatever it can be. Its size is also 8. Okay, and size of the class is also 8. So this is nothing but a pointer. So we can come to a conclusion that this is a pointer which is pointing to something because the size is still remaining at 8. Okay.
But
Uh,
the pointer symbol is not there. Means like star.
See, this is my assumption. This is there is no declaration at
No,
all.
no. Means okay. No, no. In that code means you have seen right that
See, that is not
For
also
Greeks. In that
that
For
is
Greeks also it is not
it is
coming
not
no for that.
declared.
So,
No one knows the
hmm.
data type of what is the return type, etc. and all for this. So they
Okay.
have written an assumption. This is not something which is going to be compiled. This is just for our reference. There is going to be a pointer. What is the return type, forward type, we don't know because this is pointing to a vtable. So the actual syntax can be v vtable star is equal to some address assigned by compiler. Okay, it's going to be like this. Okay, now we can derive one more class. Let's see what happens. Now I derived a class. I wrote a class which is derived from a base class function. Now in this, what I can do, I'll comment out everything. So this is going to be a plain derived class. Okay. Now let's see what. So what is the size of the class? Both base class and derived class will remain same. Okay, because derived class is just inheriting a class which has one uh, virtual function in it. Okay. Now, but he has not overwritten any of them. Okay. Now let's see what happens if you overwrite it. So now if you see this guy has a function, this guy is overwriting it. When he overwrites it, what he is doing, he is just rewriting it. If someone calls this function base class function, it will print class of fun. Whereas here, if he does derived class of fun, what it will do? It will print derived and fun. Now let's see what the size is going to be. See, now even now the size will remain at 8. He is not, this derived class is not going to inherit or copy the v pointer from here. Rather, he will have its own v pointer. Inside that, he will have addresses of the function which he overwrite, which he has overridden, and two functions which he has taken from a base class. Okay, just 1 minute, guys. Give me 1 second. Uh, any doubts on this, guys? So far, you are able to understand this topic or not? So in the base class also, you see only one vptr. In derived class also, you see only one vptr. Okay, but they will have the addresses of these functions which they are going to overwrite. Okay, so we'll see this examples completely here. Inside that, we can try. Okay, how to access those members or not. Okay, so there is one more important item. Okay, so one more important item is okay, let me take this class. So before I go to that example, you guys are clear, right, on this? Anyone has any doubts with respect to this pointer table? How compiler assigns one pointer table internally?
Yeah, understood.
Okay, so the next question can be is, so first question is how the compiler gives us this runtime capability is via with the help of pointers. Okay, for every class having virtual functions, compiler will have its own pointer added to it, and that become with the help of that pointer you can access the actual functions. Now the topic comes is what is the location of this in memory? Like, so I created a class, okay, which has int as a variable. Okay, it has int as variable. After that, I wrote a function. After that, I wrote a function virtual. Now the the person will ask you a question like where can okay, I'll open a it has integer x and it has one virtual function. So now in a memory, okay, okay, when the class address starts, right, like address, let's its address be 0x345. Okay, now what should be the first thing that it should show? Should it store integer of x, or should it store underscore vptr, or should it be in this way? Which one is correct is what a question can come for you guys. Okay, so assume this is a memory address. Okay, you have created a instance of a class. Okay, now the address let the address that it assigns can be 12124. Okay, now in this address is it going to store integer or v pointer first? Okay, this can be a question for you guys. Okay, what do you think that compiler will actually assign for? Okay, they'll answer it. So the compiler will try to assign v pointer first. So the compiler will always try to assign v pointer first, then followed by variables. Whatever that you declare here, right? Then it will add in the next sequences. Okay, we can verify that. Also, there is one program here to verify it. So you assume if you see you have a class here which has an integer followed by another integer. So it has two integers and he has written some couple of functions get x and get y, and he has written one destructor, okay, which is virtual. Okay, whether this can be virtual, this can be virtual, or this can be virtual, it doesn't matter, any one of it can be virtual. Okay, so next what he has done is he has created one a pointer. So he has created an instance of this object. Okay, c point is an instance. Okay, c point is a class and obj point is the instance of this object. Now what he has done, he has taken address of it. Okay, now he has taken address of it. Now let compiler assign some address. Now what he has done is he has typecasted the c point address to int. He has typecasted the address of his to int. Yeah, give me 1 second actually. Yeah, sorry guys. Okay, so you have a class, an instance, and he has typecasted this to an int pointer. Okay, so the p int is going to be an int. Okay, next he has incremented by 1. He has incremented it by 1. Okay, so and he has assigned some value to it. So he has assigned some value to it, assuming that he wants to change the x. So if you see the start of address is class and he has assigned some 100 value to it. So assuming he will change the content of this int, okay, m of I of x. Next, he incremented it again plus
Sir,
2.
again, voice is breaking.
Okay, you guys can hear me now?
Yes.
Okay, okay. So what his intention is p of 1, p of 1. See if you see p of int is pointing to the start of the class. Okay, now p int plus 1 is what? P int plus 1 will be plus 1. Plus 1 will be m of I of x. So I'll write that in an Excel sheet here. Let's take this class c point. So class c point.
Please unmute.
Hey, okay, sorry. Now you have a class. It has two variables, m int of x, m I of y. Okay. So by default, the compiler will assign v pointer at the start, his address. Okay. Assume some address. It can be some random address. Okay. So at the start, he assigned vptr, then followed by m I of x, then followed by I of y. So this can be plus 8. What can it be? 32. Okay. Okay, it cannot be 32. 24, right? Plus what is C? It should be C. Now what can be C plus T? 12, 20, 1, 4. It can be 3 and 4. So it is, so the memory addresses for each variable will be something like this. Okay, it's v pointer for this. Okay, this is an integer, right? So size of int is 4. So it won't be 3, 4. It will be 0. Okay, so it's going to look something like this. Okay, now when it happens like this now, uh, we can compile this and see what it is going to do. So what he has done is he has declared an object obj point. Okay, and he has just taken the address of this class. Okay, and plus 1. He typecasted it into int pointer. He typecasted this pent to some int pointer, and since you are incrementing it, right, it is going to a next memory locations, and you can assign some value and see what the content or what the value that you can see. If you see, it has assigned x. So x value, this has become 200. Y has become 10. Y is remaining at 10. So why is it? Because if you see 5, the initially when he assigned it, right, I'll explain this. 5 and so the constructor, so the constructor has assigned an initial value of 5 and 10 to it. Okay, then what we have done, we have taken the address of this. Okay, p e of int, but we incremented plus 1. It is just an int pointer plus. Okay, he wanted to change the address of x. Okay, so he took this address and typecasted it into int. Okay, and plus 1. So but what happens is you just incremented it by 1. So it is going to just increment by 4 bytes. Okay, just some 4 bytes. So because of that, it didn't actually reach this instance. Okay, it didn't actually reach this instance. So but when he did second increment, which is this. Okay, so here only plus 4 has been added and one more plus 4 has been added here. Okay, so this is where he is trying to assign 200 to it, but whatever the address that he assigned na, here, that went and sat somewhere in between. So between maybe 1204 or 1228, somewhere that it went and sat. So when he has done something like this, the address would have been become 0x 1 2 1 2 4 plus 4 is 8. Okay, and second time when he has done something the same, right? So it would have become this address plus 4. Okay, so when he did plus 4, okay, the address is pointing to this side, this one. Okay, so that's when, okay, it came and assigned some value to the x memory location somewhere here. Okay, so that's when after assignment. So after assignment, what it has become 200. This 200 is assigned here, but this will remain same. This is not altered. Okay. Now, if you want to alter this, okay, we can do this again by just doing this. We will make it 3. Now let's see what will happen. See, now this is where the address of y got changed. Y is nothing but vptr plus 4 plus 4 plus 8. So from here to here, the difference is 8. From here to here, it is 4. Okay. That's how the constructor allocates addresses to the pointers or internal variables onto it. So you guys want me to repeat this one, or this is too much to digest? Think this topic, okay, uh, all these VPTR topics, okay, only if you are able to answer the initial part, that this part, okay, this should be more than enough. Okay, if you nothing else is required, the topics which are here and all are may not be required. This is extra and all, and no one uses this. It is just for some explanation that they had given and all. That's all. But,
So in application development, how this concept will be helpful?
so this is like hacks in application development. No one will directly use the v pointers and all. Okay, so because you cannot write v underscore pointer at all. If you have objc objects of c dot underscore vptr, something like that, you cannot actually write it. Okay, so you cannot use this for coding, but you can use this for understanding how this works. It is just a theory of how the compiler assigns that uh, addresses, pointer addresses, for virtual functions. Okay, to understand that concept, you need to understand this tables. That's all. No one will ask you to write a code with the help of v pointers and all, because you cannot access this. This is extremely private variable. You cannot declare anything to use it. The only way, if you want to hack it, then you can use the exact address of this. So here you typecasted it to int, right? You can use this address, and then you can make a call to this functions and all, virtual functions and all. That's how you can use it. Or you can debug whether a function has been overridden or not. Something like that, you can do that and all. You got my point?
Yeah, yes.
Okay. Because in order to access value of first entry in vtable, okay, the value of virtual pointer, that is the address of virtual table. In order to get that, you need to write a code like this. All these are for demoing purpose. Okay, if I just want to print the value of this, the v pointer, I need to write a code like this. Okay, address of class plus 0. It has actually no meaning, but you need to write address of class plus 0, and you are typecasting into int to something else. And then if you do this, then it will print something like this, value at v pointer. If you see what it, address of virtual pointer, you will have then value at virtual pointer address. So all these things you will have. So this is may not be much important for you guys, but just if you understand the theory, that's more than enough. Yeah. If you have any questions on this, you can ask me now. Okay, now virtual functions or how this v pointer is actually helping us. That's all. Any doubts or any questions on this? These all these are extremely complex. I don't want you guys to get confused on that. Okay, I think that's all I had. The concept of viewpointers. Okay, so how the compiler gives us this facility. Okay, so basically, what happens is, so whenever you declare a class, an empty class, the size will be 1. Okay, but even when you declare a function, I mean a function inside empty class, the size will still remain 1. But the moment you add a virtual keyword to any function, the compiler will put a v pointer inside it. It's a v pointer, it will put inside it. It is nothing but a pointer to a table. It's a pointer to a v table. This table is internal to the compiler. It is not something developer can use or should use. Okay, so he just introduced this and he will fill it up with the address of this tables, of this which we pointer table. Now what is this v table? V table is a array, or you can say it a table which has addresses of all the functions which are virtual. Okay, so this is a virtual function. So it is now if you add one more function which is not virtual, it will not get into the table. Okay, it is just going to have only those functions which are virtual. Okay, now if you derive a class, the derived class will also have one v pointer because the base class itself is polymorphic, which means which has one virtual function in it. So the base class itself is polymorphic, which has one virtual function. So derived class will also inherit that property. Okay, here this is your derived class. Okay, so derived class will inherit the properties of base class, wherein he's going to have a v pointer as the same as base class, but this v pointer is going to point to a separate, this v pointer is going to point to a separate table. If you see here, v table of derived class 1, here v table of base class. So the v pointer for this derived class will point to this. Okay, so all the functions address will be stored here. Okay, and similarly, if you derived a third level, okay, the third level derived class will also have one v pointer, and it is going to have one virtual function. If you are overwriting function number 2, so only the overwritten functions address is stored here, and this function is already overwritten, so it will also get stored with derived functions address. So the base function was written here which has virtual, so his address is going to come and store here. Okay. Hope I'm able to explain this concept for you. This is a tricky. Okay. This may not be much interesting, but because we didn't write any code in that, or I think we wrote only two codes. Okay. So tomorrow I'll cover this static casting and dynamic casting. So that should be a very important topic for you guys. This dynamic cast and static casting. These two are going to be important topics because most of the questions will be like, what is static casting, dynamic casting, or what is the difference between them? So your interview questions will be based on these two questions only. Okay. Any more topics you guys want me to cover apart from this? Once I done this, then I'll do exceptions. Okay, then maybe we can touch up namespaces. That's fine. Then we need to write class templates also. So that's when we are done with C++. Okay, maybe then we can start Linux. Okay. STLs you guys can study, right? Or you want me to cover? Because STLs is going to take 2 or 3 weeks if I start. Tell me, guys.
Sir, what is STL?
It's like uh, class templates, standard template libraries like arrays, vectors, bit sets. You would have studied this data structures, right? What is an array? What is a map? What is linked list? Okay, so all those C++, they have written their own way of implementing arrays, vectors, linked list and all. Okay, sets, maps and all, they have implemented it. We can just use them. Like it's not like you need to write your own linked list program and all, because a C developer will write all the linked list programming and all by themselves manually. But whereas for C++, C++ itself gives you those linked lists and all. And whatever data type that you have, you can create a linked list of them. Okay, this is more of a data structure related concepts.
Then end of the Linux means after the Linux you can go.
Okay, because it's going to take 2 or 3 weeks, guys.
Yeah.
And I want you guys to do programming because I can uh, do programming by myself. But if you take this, I can give you introduction for this, what it is. But if you do some online competing programs like hackathon codes for this, that's when you will understand what STLC is about. Else, there is no point in me giving and you not doing. But this is important. Class templates are important. The moment you do class templates, so rest everything is class templates only. All these are class templates implementations. Okay. Okay, guys. I think that's all I had.